I'm Wenli. Today's topic is dummy variable. Dummy variable is like Bernoulli variable, okay, which takes value 0 or 1, only two values. When you encounter that kind of variable, dummy variable, in regression analysis, you have to know how to use it, how to interpret the result. Okay, let's see dummy variable. In regression analysis, the variables dealt with are mostly quantitative variables that are represented as real numbers. Real numbers means any value on that real numbers. That is, variables such as temperature, age, weight, and scores, etc., are used as x and y. However, when using qualitative variables as explanatory variables x, it is necessary to convert the qualitative variables into dummy variables to reflect them in the regression model. Qualitative variables refer to data that cannot be quantified, such as gender, shape, color, and season, etc. For example, if we want to investigate how gender, female or male, affects Y, we must define gender as an explanatory variable as follows. Gender takes 1 if female, takes 0 if male. A variable defined by assigning values of 1 and 0 in this way is called dummy variable. It is like a Bernoulli variable. It is also referred to as indicator variable. Okay, somebody call it indicator variable. Thus, the simple linear regression model is y equal to beta 0 plus beta 1 gender, this variable, plus epsilon. Beta 1 is interpreted as amount by which woman increases or decreases the sign of beta 1, y compared to man. When male 0, okay, gender takes 0, then nothing here. But for female, it takes 1. So beta 0 plus beta 1 means female, women, increase or decrease depending upon the sign, uh, amount that y compared to man, right? Now let's consider a more complex example of a qualitative variable. Suppose we want to investigate how the sales of ice cream y vary depending on the season, spring, summer, autumn, and winter for season, using a regression model. In other words, y equal to model beta 0 plus beta 1 season here, okay, plus epsilon. A little more difficult, complicated thing rather than gender. In this case, the seasonal variable season is defined as follows. Season takes 1 when spring, takes 2 when summer, takes 3 when fall, autumn, takes 4 when winter. However, applying the defined qualitative variable season directly to the regression model is not appropriate because the unit change of a season, unit change is 1, right? 1, 1, 2, 3, 4. It will take 1, 2, 3, 4. Then the increase or decrease of y is beta 1, right? So it doesn't make sense anyway. When spring to summer, then beta 1 increase of y. Summer to fall increase 1 unit of season, then also beta 1 increase of y. We do not want that kind of result. It doesn't make any sense. There is no way to interpret the coefficient for season variable. Does it make sense to say that an increase of 1 unit is beta 1 anytime? You may want to compare the variability of y between season. How to change between season? Spring and summer, summer and the fall, and spring and fall, spring and winter, something like that. So a variability of y between season. We want to know when a qualitative variable is divided into k categories, k greater than or equal to 3, k minus 1 dummy variables should be defined and used in the regression model. In the case of season, the qualitative variable season should be defined using 3 dummy variables, S1, S2, and S3, like this. Spring S1 takes 1 when spring, 0 others. Others means not spring. S2 takes 1 when summer, takes 0 others. S3 takes 1 autumn, takes 0 others. Something like that. Okay? Then the variable season is represented by S1, S2, and S3 like this. Season: spring 1, summer 2, autumn 3, winter 4. It's going to be changed like this by S1, S2, S3. What is it for spring? S1 is 1, S2, 0, right? S3, 0. For summer, S1, 0, S2, 1, S3, 0. Get it? Autumn, S1, value 0, S2, 0, S3, 1. Winter, 0, 0, 0. So you have to use the 3 dummy variables instead of a season in the regression model. The model becomes y equal to beta 0 plus beta 1 S1 plus beta 2 S2 plus beta 3 F3 plus epsilon. Assumption, always epsilon takes normal distribution, follows normal distribution with the mean, 0, variance, sigma square. So now, how to interpret coefficient beta I? How to interpret this? So that is main point here. So I'm gonna left it to next lecture, okay, with some example. All right, that's it today. Thank you.